Hey everybody, I hope that you're doing well. And so here we are in our last section of this chapter, section 4.2. Remember, we skipped it and did 4.3, so now we're coming back for it. And so what we're doing in this section is stepping up our game. We're going to try to solve systems with 3 variables. Now, I can go as large as I would like to, but the bigger these things are, the more time and effort they take to solve by hand. So usually past 3, nobody solves anything bigger than 3 variables by hand. They use computers or calculators to solve them. But for one as small as 2, that's fine by hand. 3 gets a little bit tedious, but we could do it. And so we actually already have all the skills we need today. We already know how to solve systems. We've just never done one this big, so we kind of need to put things together. And so I kind of want to step you through 3 ways to do this, or 3 steps to do this. Only one way we're going to teach it. The first thing we're going to do is create an easier problem with just 2 variables and 2 equations. Okay? And we're going to do this by using elimination twice on the same variable with 2 different pairs of equations. That's a lot of words. You'll see whenever I go to do an example what I mean by that. So basically, we'll have 3 equations because we have to solve for 3 variables, so we'll need at least 3 equations. And what we'll do is we'll grab a pair of those 3 and eliminate a letter, and then eliminate the same letter with another pair, and try to get rid of a variable altogether. Okay? Then we'll solve our simple 2x2 system, the one that we created here. And then we're going to do what I'm going to call our super finishing move. So we already have our finishing move, but we're going to have to plug in to make sure we get all 3 variables. So I just spiffied it up a bit, the super finishing move. So let's jump right into examples and see if I can show you what I meant with all those kind of phrases of things. Alright, so we have this big 3x3 system, 3 variables, x, y, and z, and 3 equations, 1, 2, 3. And so what we're going to do first is we're going to just pick a letter to get rid of. Okay, we're going to use elimination. And so if you look, negative z and positive z, if I were to add the first and the second equation together, the z's would cancel. So I'm going to actually just choose to start there. I'm going to take these 2, and I'm going to do an elimination. Remember, an elimination is where I add 2 equations together. Now, you may have to prime it, like we learned 2 lessons ago. But if we're lucky, you'll have at least one that is easily there and ready for you. And so I can perform an elimination and add these 2 equations together. Let's see, 2x and a minus x. That's going to leave me with a positive x. Positive y minus 2y. That'll leave me with a minus y. The z's will eliminate. And let's see, 10 minus 9 is 1. So let me put this equation in a box for a second. So there is one equation I have created with 2 variables. Now, which 2 variables does it have? It has x and it has y. So if I would like to make a 2 equation, 2 variable system, I need to do the same step again, and I need to cancel the same variable again. I'd have to cancel z's with a different pairing of these 3 equations. Because obviously if I do these 2 again, I'm just going to get the same equation again. So I can use the top one and the bottom one, or I could use the second and the third. It does not matter as long as I do not do the first and the second again. So let's just take the first and the third. And so if I look at the first and the third, see if I have enough room to do this. 2x, I'm going to copy them over, plus y minus z equals 10. And what's the bottom one? Make sure I copy it correctly. X plus 3y plus 2z equals negative 5. The biggest danger in doing these problems is not the work, because the work is not hard. We knew how to do an elimination. The biggest danger is in accidentally copying things over incorrectly. So make sure that we did, in fact, copy everything over correctly. Now, I would like to perform an elimination again and get the z's to eliminate. But is this one primed? This one was primed and ready to go. Once I added them together, the z's canceled. If I add these 2 together, the z's are not set up yet. I have a negative 1z and a positive 2z. So I need to multiply this equation by some number to get this to be a 2 right there, so that I would have opposites, so they would cancel. It's already a negative, so I just need to multiply this equation by 2 to prime it. And this is stuff that we did 2 lessons ago. We've been working on solving systems, so we should be pretty good at elimination, and that's all we're doing. So notice I make sure that everything gets multiplied by 2. 2 times 2x is 4x. 2 times y is 2y. 2 times a negative z is a negative 2z. And 2 times 10 is 20. And this one we're just going to carry over x plus 3y plus 2z. Make sure I copy it correctly, equals negative 5. Always double check when you do these. X, 3y, 2z, negative 5. Alright, and so I believe we are ready to perform this elimination. Once again, we eliminated z on our first pairing, so we want to eliminate z again. Let's see, 4x plus 1x is 5x. Bring down my plus, well, we'll see if this is positive, but it is. 2y plus 3y is a positive 5y. Negative 2z and plus 2z, those are opposites, so they eliminate each other. And 20 plus a negative 5 is 15. So let's put this in a box and see what we have. Okay, now look at what we have. I have x and a y equation with just two variables. I have another equation with an x and a y. So first off, do I have 2 equations with the same 2 variables in them? Yes, I do. So that is my new system. So let's just draw a line, copy these over. X minus y equals 1, and 5x plus 5y equals 15, and forget about everything up here. So that's step 1. I did elimination twice to eliminate the same variable in 2 different pairings of these 3. And so what does that do? That creates a 2 by 2 system. 2 variables, 2 equations. So now I could even do this, block it off from your vision. If you need to go back and look at it, you can rewind your YouTube video and pause and stare at it. Now I'm just going to do what we've been doing. I can solve this system really easily. Okay? So that's where we are at right now. I guess I could just do that and scroll. So I've created this new system. Let's forget about all this for a second, and let's just solve this new system. I'm going to use elimination just because we've been doing everything through elimination so far. And notice if I multiply through by 5, this is a positive 5y, this is a minus y. If I multiply by 5, that would give me a negative 5y, and it would cancel or eliminate with this positive 5y. So let's do our priming step here to get ready to do an elimination. Let's see, and that would be 5x minus 5y equals 5. 5x minus 5y equals 5, and this one didn't need any multiplication. Let's just carry it over. 5x plus 5y equals 15. Okay, and if I add them together, 5x plus 5x is 10x. Negative 5y and positive 5y eliminates, and 5 plus 15 is 20. And so now I can very easily solve for x. Divide both sides by 10, and x will equal 2. So let's circle it. So once again, now it's time for our finishing move. So we can go back into one of the originals, plug in this x value that we found, and find y. I'm going to take the top one. Even though it has a subtraction sign, or negative y, I think we can handle that. So we're going to plug in a 2 for x. So it's just 2 minus y equals 1. Now, this 2, if you look out front, it's a positive 2. So to move it over, I'm going to subtract 2. Because this negative sign belongs to the y. There's nothing out front, so it's a positive 2. So I'm going to subtract 2 from each side. So that negative sign still belongs to the y. 2 minus 2 is gone. And 1 minus 2 is negative 1. So if negative y equals negative 1, that must mean positive y equals positive 1. Alright, so yay, we have solved our simple system. Now we can finally think about the original problem. The original problem had 3 variables in it, x, y, and z. We have found 2 of them, x and y. So all we have to do now is what I deemed our super finishing move. Super finishing move. Okay? All we have to do is take one of the originals. I'm going to take this one because it has just a single little simple z. Well, maybe the bottom one would be the easiest because these are all positive. Let's take the bottom one. X plus 3y plus 2z equals negative 5. And I'm going to leave a blank for the x because I know that variable. A blank for the y because I know that variable. And copy everything else down exactly like I see it. So I can use any of these three. I'm going to use that one because it looks the easiest to solve for z. And I know what x was. It is 2. I know what y is. It is 1. And so what I can do now is simply solve. Let's see, what is 3 times 1? That is 3. I can solve for z. Now be careful here. What's 2 plus 3? That's 5. And so that is a positive 5, so I will need to subtract 5 from each side. And what I get is 2z equals negative 10. And divide both sides by 2. And kind of out of space, so well, I guess I can scroll down a little bit more. And so z will equal negative 5. So there, I have found all three variables. Now, once again, this is going to be written as an ordered point, not an ordered pair because there's 3 of them, an ordered triple, and it'll be in alphabetical order, x, y, z. So let's see. So 2, 1, and negative 5. Put them in the correct order. So there, we have finished it. Now, there is our answer right there, 2, 1, negative 5. So let me ask an important question. We did solving. Every time we've done solving, we've been able to check our answers. So if I had time when I took the test, could I check this answer? And the answer to my question is absolutely. We would go up to the originals and plug in 2, 1, and negative 5, and it would need to make all three equations true. If it made all three equations true, then that is indeed the correct answer, which we didn't make any mistakes. I know it's the correct answer. Okay, so that took a lot of work. It took a while because I explained a lot and went really slowly, but it's essentially 3 steps. Eliminate the same letter twice. I had to grab different pairings. Once you've eliminated the same letter twice, you have made a system of 2 equations. Solve that system. And then super finishing move. Plug into one of the originals to find the last letter. So let's do it one more time. Let's practice with another example. Here's another one. And I really should mix up letters so that the z's aren't always so easy to eliminate. But notice, once again, the z's are really easy to eliminate with these first and second. Now, I do want you to know you don't have to choose the z's. I could try to eliminate the x's or the y's if I wanted to. It's up to you. It's perfectly fine to choose any letter to be the one you eliminate twice. It just so happens that the problem I wrote, for some reason, the z's, I must not like z's. They are way easier to eliminate. So let's do that. Let's first make our easier system by eliminating z's. Now notice, these are already set up to be opposites. So I can just take these, 2x plus 4y plus z equals 9, and this one 3x minus y minus z equals 13. So they're already opposites, so I can go ahead and do an elimination there. Let's see, 2x plus 3x is 5x, 4y minus y is going to be positive 3y. The z's will eliminate, and 9 plus 13 is 22, right? So there, we have one equation. I do want you to stop and look. It has an x and a y. So that means I need to do another elimination with another pairing, and I need to cancel z, so I end up with an x and a y again. Let's grab the second and the third, because this is a negative z, this is a positive 3z. I would need to multiply this by 3 So I'd get a 3 here and a positive 3 here. They would eliminate. You can start to show your work a little bit faster if you wanted to write what you're going to multiply by over here. But be very careful copying this over. So 9x minus 3y minus 3z equal sign, and don't forget to multiply over here. That's the most common mistake people make in multiplying. 13 times 3 is 39. And then I can just copy this one over. X plus 2y plus 3z equals 12. And let's make sure that looks right. X, 2y, 3z, 12. Okay. Now I can do my elimination. Let's see, eliminate these. 9x plus x is 10x. Negative 3y plus positive 2y is going to leave me with negative 1y or negative y. Negative 3z, positive 3z are opposites. They eliminate. And 39 plus 12, let's see, that will be 51. Yep, 51. So there is my system of equations. I hope I haven't made any mistakes. Those seem like big numbers, but that's okay. Big numbers can happen, right? So look at what I have done. I have finished step 1. I have done an elimination twice on the same variable to end up with 2 equations with the same 2 variables in them. So let me copy them over, and we will now do our 2 by 2 solve, which we already know how to do. So make sure I copied them over correctly. So I'm going to do elimination again. And I notice if I look right here, this is minus y and this is plus 3y. So they're almost opposites. This is a positive, this is a negative. This one's a 3y, this one needs a 3. So I can just multiply this by 3. So I multiply the bottom one by 3, kind of doing the priming step, getting it all primed and ready to roll. So multiply by 3. So what will that give us? 30x. 3 times minus y is going to be minus 3y equal sign. And 3 times 51 will be 153 if I did it right in my head. Yeah, I had to think a second. And let's just carry this one over. 5x plus 3y equals 22. So now I can do my elimination. 5x plus 30x is 35x. Positive 3y, negative 3y eliminates. And 22 plus 155, let's see, that'll be 175. And then I'll have to divide both sides by 35. And you'll probably want to use a calculator because these numbers are getting big. Let's see, let me think. Oh, what would that be? That would be 5. That would be 5. So we found x, so we could do our finishing move. And let's plug into this one just to avoid the negative sign. Or we could plug, it doesn't matter. Let's plug into the top one though. 5 blank plus 3y equals 22. Let's see, and what is x? 5? Put in our 5. 5 times 5 is 25. I'm going to need to subtract 25 over. Oh, computer slowed down. There we go. Come on, right thing. Subtract 25. Now that'll give me 3y equals 22 minus 25 is negative 3. So I'll need to divide both sides by 3. And y will equal negative 3 divided by 3. That'll be a negative. 3 divided by 3 is 1, so a negative 1. So I have found x, I have found y. It is now time for our super finishing move. Okay? So what that means is we need to go grab one of the originals. It does not matter. I'm going to use the top one this time. They're all positive. This looks really easy to solve for z. So let's make sure I copy it over correctly. It's 2x plus 4y plus z equals 9. And I know x and y, so let's plug those in. So 2 blank plus 4 blank plus z equals 9. So let's see, what is x? 5. I didn't leave myself much space, did I? And y is negative 1. So now let's do just the arithmetic here. 2 times 5 is 10. 4 times negative 1 is going to be negative 4. 10 minus 4 is 6. And then I can finally solve for z. I can subtract 6 over, and z will equal 9 minus 6, that's 3. And so I have found my x, y, z. X, y, z. And I could plug this in. I could plug this into all three of the originals, and it would make all three of those equations true. Okay. Now, I want to show you one other example. So these two are going to be like the ones on the test. Okay. The first two I have done here are the ones you'll be responsible for on the test. But on your My Math Lab, they may do some with missing terms like this occasionally. So you see it's the same thing. I have x's, y's, and z's. It's still three equations, but I have some missing terms. But I'm not going to solve this one all the way through, just for the sake of not boring you. But it will be on your My Math Lab. But this one takes less work, because you notice I already have an equation with just x and y. So if I can combine these other two and cancel z, let's do that. It's actually already set up to eliminate. If I were to add these two together, negative x, it's a positive 2y, so plus 2y. Z's cancel. 3 and negative 17 is what? Negative 14? Now look at what I have here and here. It only took one elimination, and I have two equations with the same two variables, x and y, x and y. So I could jump into the second step a lot sooner. So if it's missing terms, like when you do your My Math Lab homework, those are actually meant to be a little bit faster. Although sometimes they don't show the spaces, and it really messes with my eyes if they're all smushed together. So you may want to write it out spaced out with the blanks for all the ones that are missing. But that solves just the same way. So I have my system of 2x2 system. I solve those two equations. Then I do my super finishing move. It's really easy. Compared to these took a lot of work. Okay. Well, that's all I have for you today. We'll look into test next class. So if you I'll try to send an email with all the information on that, and that'll be, I think, Friday. So have a good day, guys.